It's awesome to be here. The stage is amazing, and I'm gonna talk about Terraform practices, and hopefully in a way that will cover not only specific bits and pieces regarding Terraform usage, but also hopefully will make you think about Terraform in a broader context rather than just an infrastructure as code tool. So, okay, so first of all, hi, my name is Hila Fish. Thank you for the applause. I'm a senior DevOps engineer. I work for Wix. I have 15 years of experience in the tech industry. I recently joined the AWS Community Builders program. I co-organize conferences, as Evan mentioned. I'm mentoring courses and communities. I think that really DevOps helps drive companies to achieve great things. And I'm a lead singer, as you can see in this picture. It is a lot of fun. Okay, so Terraform implementations can sometimes be good, bad, and also ugly, and I will cover some of those here. A small disclaimer, I'm going to show mostly examples from the AWS provider, but Terraform works with any cloud provider there is. And I only use Terraform open source, not cloud and enterprise, so all the examples I'm going to show here are from the open source version. I don't know if they apply to cloud or not, enterprise, but I assume that they have even more advanced features. Okay, so quick wins. When I say quick wins, I mean things that you can do and achieve in a matter of minutes when you work with Terraform. So first of all, versions lock, same as you have for other programming languages, requirements txt for Python, and packages JSON lock. Same goes for Terraform. You can lock the modules, providers, and Terraform versions, like you can see in these examples, and that way you know exactly which features are in that version and which syntax is really is acceptable. And as you can see from this meme by Anton Babenko, who's like a Terraform celeb, sometimes we have provider issues, so it's better to lock the versions and deal with the devil that you know. So the good thing here is to lock the modules, providers, and Terraform versions, because then it will allow you to avoid any issues. The bad thing is to lock in a way that will still allow breaking changes to occur, because then if you lock to a minor version, not major, then still some issues could happen, and we want to avoid that. And the ugly thing is to have no versions lock whatsoever. Believe me, you don't want to do that. You'll have syntax issues. You have a lot of things that you don't foresee. So try to avoid that. Next up is tagging resources. So tagging resources is awesome to have cost management efficiency and to be able to track your cost expense, and for like logical arrangements of projects where we want to know which projects available, and we can know that by tagging them. So these are examples of tags that we use in Wix, but you can use whatever tags that makes sense to you. And you can use default tags that you define on the provider level, and then once you define it, then all resources that were created by that provider will inherit these tags, and that's awesome because you just set it once and forget about it. So the good thing here is to tag everything that you can, use default tags as much as possible, and also PR enforcement is something that I'm going to cover in a bit. Stuff that you can, like checks, logical checks that you can set up in a PR, that if someone didn't added tags to the resource, then the PR will fail its merging. It's good to have, and I will cover it in a bit. The next thing is to tag inconsistently, because as we know, consistency is key, and if you are in charge of the cost management, then it will be very hard to do, and if you do tag, then if you do tag, then your FinOps team will be really happy that you do. And if you don't have FinOps team, congratulations, you are the FinOps team. So please make sure that you tag and consistently, because it will help you in the long run. And the bad thing, and the ugly thing is to have no tagging whatsoever. You will lose track about your infrastructure very easily, so try to avoid that. And the last thing in the quick section, the quick wins section, is remote state. So by default, Terraform works with the local state. So in order to have ability to work with other teams on your Terraform code base, and in order to have audits and have backups and stuff like that, you should define the Terraform to work with the remote state configuration. So The good thing is to have your state remote and backed up and secured, of course, and to have Terraform state lock, because if someone runs Terraform while you run it, then there will be collisions, so it's not great to have. So try to avoid that and have state lock so everyone runs it and the state gets locked when it runs. And basically, the other way around is the ugly and the bad. So local state, and state is remote but not backed up and not secured, and the state doesn't get locked during a run. Okay, so these were quick wins, and really, there are simple things that you can implement in order to be best and achieve great things with Terraform. Let's talk about second nature. And when I say second nature, I mean things that you should think about on your day-to-day when you work with it, and that will help you along the way. So first of all, community models. A lot of well-known cloud providers' features are already covered by models that are created by the community, so might as well use them if they fit your use case, rather than reinvent the wheel and create models yourself. And these community models, when they are verified to be good and that they are really in use, it's good because they are proven over time and they are supported by the community, and you avoid and you eliminate the need to support that because they do it for you. So it's also good to have to use that. And the thing about community models is they have the practices enforcement that I'm gonna share in a bit, to make sure that people can contribute code, but the code stays in a high quality state as much as possible, and to onboard other people to use the code. So that's awesome to use community models in this regard. So the good thing about community models is to use the verified ones, so either the ones that in the Terraform registry or just the ones that have a lot of downloads, that way you know they are safe to use. The bad thing is to create a custom module of your own while a community module exists that fits your needs. But if you still maintain it as such, you know, you have practices enforcement and you make sure everything is okay, then it's still quite okay. And to have a community module without a version lock, this could also lead some issues. And the ugly thing is to have a custom module that you created without maintaining it, and to have unverified community module usage, because that way you may be exposed to malicious configuration, and you don't want that. And if you do have to create your own module, so make sure you make the module as stateless as possible, clean, you do not repeat yourself if you don't have to. And basically try to incorporate the enforcement that I'm gonna cover. I know I'm doing like a build-up for that, but trust me, it's worth it. Okay, next thing is variables versus locals. So variables, as we know, just straightforward, we just define them, as opposed to locals, where it's much more complex and you can do much more conditionals when you work with them. So this is an example of tags that you can define once and have the local run with this tags configuration throughout the implementation, because locals doesn't change the value between runs. So on the module side, use variables as a setting for the module configuration, but always aim to set default and validation, because if not, and someone will use that module, then the module will break if a value wasn't passed to that variable. And in regards to locals, then it should be used like a constant to be relied on. So for example, if I have a module that creates an S3 bucket, and I want to have naming convention, right? I want to make sure that everyone uses this this module and have a consistent naming for all of our buckets. I can achieve that using local, like in this example. So you can do whatever you want, and it could be really like a constant to be relied on, and force people to use it in a certain way, but in a way that will make sense to you and be like in your best guidelines that you need to aim. So that was on the module side. On the live side, and when I say live, I mean where we call the module. So like a module is a class, and then the live is instantiation of the class. So variables on the live side, if you use them only once, you just set a default. But if you use them per region, then you should use the tfvars file that help you achieve these settings per region. And on the live side, you should avoid using locals, because we want to aim to have like as simple as possible live side, because we want all the logic to be kept on the module. And use data sources to fetch data from your actual configuration, your actual infrastructure, and pass that to the module. Because that way you can have dynamic configuration set up, and you don't need to set up any hard-coded stuff. So the good thing is to use TFRs whenever necessary. Utilize environment variables, because that way you don't have to create more variables if you can just have environment variables to be used, and that's that. Use locals to de-hard code one-time names and decrease code repeatability, and try to keep things as generic as possible. People need to maintain it afterwards, so don't overcomplex things. The bad thing is to use multiple blocks of locals. Terraform allows that, but it will be hard on the eyes and hard to maintain. So if you don't really have to have multiple blocks, so try to avoid that. Decentralized vars is also not good. Just have variable files that has all variables in them, because then it will be hard to maintain, and ignoring environment variables. And the ugly thing, as we can probably guess, hard coding variables when the values are need to be changed, because variables are exactly that. They need to vary, right? So try to avoid hard coding if you don't have to. Okay, file structure. So when you create a model, or even on your live side, you can do a lot of things with the files themselves, because Terraform just execute whatever files that has the suffix of TF. But we want to have logical arrangement and easy management of the code, so we can arrange it and take example from the community as well. So on the community models, we can see main TF, which holds the main logic of the module, and then variables, data, and outputs. And if we have other peripheral stuff, like, for example, I have a module that creates a VM. So I put the resources to create a VM in the main TF, but let's say I need security groups, so I need load balancer, so I will put them in separate files to have this logical arrangement. And if you created a module that is pretty much complex, you should consider creating like submodules and break it down, because that way, again, logical arrangement, and you can also reuse some part of the code. So for example, also from the community standard, VPC module has a submodule of the VPC endpoint, and EKS module has submodules of the node pool creation. So it's always good to have this flexibility, to reuse stuff if you can, and to have logical arrangement that will help you organize things in the long run. Okay, this part I like. So applying classic code best practices on Terraform. I'm not saying that Terraform is a programming language, okay? The honor of programming languages lies, but the thing about Terraform is that even HashiCorp, the company that created Terraform, realized that code best practices should be applied on Terraform as well. And how can we know that? Before Terraform 0.13, we couldn't even loop over modules. And since this version got released, we were able to call modules several times in a single module call. So this is very important to apply classic code practices on Terraform as well, because it works in the same way. So keep the Terraform code in source control management. Keep the code as simple as possible. Do not repeat yourself if you don't have to. Even functional programming aspects and principles can be applied on Terraform. The code should be idempotent. And in regards to human and clean, I want to quote something from a great article that I read about from T.C. Ngu. He said, and I'll have a reference slide afterwards. He said, and I totally agree, that computer that processes code doesn't care if your variables are ambiguous or not clear, right? It will execute anyway if the code syntax is correct. But we need to have naming conventions and stuff like that to be, for us, for the sake of us human beings, to be able to maintain it better and in the long run, and not, curse the other person that did a spaghetti job and now I need to maintain it, right? So all of the principles of best practices of code, like refactoring, naming conventions, also things should be applied on Terraform, so it will help us human beings to maintain it better, so for the sake of us human beings, and not the computer that can do whatever he wants. It wants, I don't know. Okay, so we talked about quick wins, right? The things that we can achieve in a matter of minutes. We talked about second nature, things that we should think about in our day-to-day in order to work in an efficient way with Terraform. Let's talk about the long haul, things that we should plan ahead when working with Terraform. So for that, I want to ask you this question. How do we envision the infrastructure and the company's needs? Because we should really think things through, and planning ahead will allow you to enable others on their Terraform journey. And you will be able to set up guidelines and best practices of your own, like tagging usage and anything that makes sense to you, and help utilize Terraform in the best way possible. And I also want to tell you a story about that. So in one of my daily syncs with my company, with my team, we had just a really daily regular meeting, and we discussed the possibility of moving Presto, because I'm in the data engineering group. Presto is like a tool to query data. We discussed to move it from a cluster of VMs to Kubernetes. And then all my team members said, yeah, let's move to Kubernetes. It's cool, it's awesome, yeah, blah, blah. And me also, I thought about it, and I said, yeah, I worked with Kubernetes before. I want to work with it again because it's very highly adopted, in a lot of companies. It will help my career, I want to do it. But at this point, I didn't say that because it's me, and it's what I want. And I said, let's think about what the application needs. Okay, so even though I want to work with Terraform with Kubernetes because it will help me, we need to think about what the application needs. And if Presto doesn't know how to work with Kubernetes, or we don't have other use cases in production, we need to think about it and not just run just because it's a nice buzzword and we want to work with Kubernetes. So this is one example to really think about what you need and your application needs, and that's why plan accordingly, even when we work with Terraform, because we can do a lot of things with Terraform. And let's take this notion and see what I mean about that. So first of all, structuring your Terraform code base. You can do a lot of things and structure it in different ways, but if you plan ahead, you can really do it in a way that makes sense, and I will show you an example for that. So this is how we structure the Terraform code base in Wix. So we have team, project, cloud provider, and region. This is an example. So live and modules, as we said. Live is where we call the modules, then the modules. And then BI is for team, Airflow is for project, AWS, the cloud provider, and US East 1 region. Why did we choose to structure the code base like that? Two main reasons. One, to enable anyone use Terraform. We use Terraform only in one code base, and that's it. And then every team has their own folder, and GitHub has code owners that allows us to approve our own PRs when we set up the code under our team. And that way we are independent and can just run Terraform and approve our PRs without having our platform team have to approve it as well. And that way everyone can just onboard and use Terraform and have references, and really, the entire R&D is using this code base that we have, and it's awesome, very easy to use, very easy to onboard others, so that's great. This is one reason. The other reason is that in this structure that you see, the state file is kept in US East 1. So it means the state files only holds resources for Airflow, for the BI team in US East 1 in AWS. Why is it important? Because Terraform creates dependency tree, and once it needs to run things, dependency tree is the thing that it relies on in order to apply things. And sometimes Terraform doesn't create the valid dependencies that it needs. So sometimes you will change just a tag, if your state file is huge, you'll see in the plan that it's going to destroy a resource. And I'm like, why? I just added the tag. What's going on? Because of the dependency tree. So that's why you should really aim to a structure, even if you don't select this specific structure, but you should aim to a structure that will have the state files as small as possible, because we want to avoid big blast radius because of the dependency stuff. So that's why the two reasons why we chose this structure. It really works well for us. I want to cover also workspaces. So workspaces are like an isolated unit. When you have the same Terraform code, you have different workspaces, and then you can apply them and whatever happens in one workspace doesn't affect the other workspace. So you can use it when you have same Terraform config for, let's say, different customers, right? Like every customer is, let's take GCP for example, each GCP project is a customer, each project is also a different workspace. And that way we have the same code base, just different workspaces, and that's that. And coupled with it is we have a lot of customers, but all of them need to use the same service in a region, right? Like financial service or login service. That could be also in workspaces. Some notes about workspaces, though, is that you should really consider using some sort of a Terraform wrapper when you work with it to avoid human errors, because how do you work with Terraform? With the CLI, Terraform workspace select X. If I forgot to do the select, production incident, okay? So try to avoid that by using a Terraform wrapper. In my previous job, we used just a Python-like mini system that ran Terraform for us. We never ran Terraform our own, just through this wrapper. You have less visibility because unless you use the Terraform workspace conditional in the code, you don't even know that you have workspaces. And even if you don't, and you do like Terraform workspace list to see the list of workspaces that you have, let's say I have 10 workspaces. It doesn't mean that they are in use, okay? So you don't have much visibility with working with workspaces, so you should really think about that before you decide to go with workspaces with your implementation. Another thing about workspaces is that from the documentation of HashiCorp, they said that use workspaces to manage multiple non-overlapping groups of resources with the same configuration. So this suggests that it applies for multiple environments, regions, locations, accounts, right? All the things that I covered. But also from the documentation, they say that multiple deployments of the same infrastructure serving different development stages, staging versus production, named workspaces are not a suitable isolation mechanism for this scenario. So I don't know, in my entire career, I haven't used the same infrastructure for both dev and production, so I don't know if they meant that or just separate environments and that's that. But if it raised question for me, maybe it will be for you. So this is another reason why you should consider and think things through before you go with workspaces on your implementation. And at least we can think about workspaces in one way. A classic usage is like a side branch. I can create a workspace, test my syntax, see everything is okay, and then apply it on the default workspace, which is the production. So to sum things up in regards to structuring your Terraform code base, if you plan ahead and think things through, then you will be able to have small states set up and set up Terraform as a platform and enable others in your company to use it as well. The bad thing is that if you don't plan ahead, then organizational changes could maybe require you to change and restructure the code, and we don't want that. We want to restructure the code because of reasons that we control, right? And another bad thing is to use the workspaces for the wrong reasons, when I just mentioned. The ugly thing is, really, if you structure the code base in a way that will allow huge state files, believe me, you don't want to go down this path. You will have invalid dependencies, big blast radius. It's not fun. It will waste a lot of your time and maybe even incidents, so try to avoid that. Let's talk about Terraform execution. So you should always aim for remote execution because that way you don't have the need to have local credentials and local configurations. And you can work with other people, right? Because the state file is not in your you don't run it, and people don't know what did you do, right? So audit is very, very important. You should run Terraform apply with a plan file because that way you know exactly what you are applying. And you should set up Terraform timeout because I sometimes had to create auto-scaling group with Terraform and I used spot instances and then the price wasn't right. So I had to wait and wait and wait until I had the timeout. So just make sure the timeout is set up to something that makes sense to you. The bad thing is to execute locally because, again, no audits and you need local credentials and local configurations. And the ugly thing is to execute locally and run Control-C when you run Terraform apply. I did it when I just started out with Terraform, and it messed up my state. I don't know if they fixed it by now or not, but I don't want to find out. So try to avoid that. practices enforcement. So this is what I had this build up this entire talk because it's very, very important. This will allow you to set up any guidelines, any checks that make sense to you in order to, first of all, have the code in a high quality state, but it could be any guidelines that you want. Let's say I want to make sure tags are added. I can add a check for that if someone didn't add tags, the PR will fail to merge. I want to, I don't know, if I added resources more than $20,000, I want to alert someone, FinOps team. We can do that also with PR, with practice enforcement. So you can set up any guidelines that you want. I showed you that this is done also on community module. So let's see an example for that. This is from the AWS auto-scaling group module. As you can see, the person that created this community model, if I'm not mistaken, it's also Anton Babenko. He added these checks. So he checks if the contributor formatted the code with Terraform FMT, added documentation, write a working code with TF-lint. You can also use superlinter if you want. And that way, he checks that the code is in high quality state and everyone can just open PRs and contribute to this model as well. So the good thing is to have pre-merged linters, formatters, and logical checks. You can do it with either GitHub Actions or pipeline checks from your CI. You can also have Slack bot drift reporters if you need so, but I can share with you that at Wix, we have Atlantis working with our PR, so the PR automation is done with Atlantis. When I open a PR, Atlantis runs a plan. I see that everything looks good, and then I run Atlantis apply. Once this is done, two things happen. First, the code gets merged, of course, to main, but also it gets applied. So that way, it makes the notion of the main equals the actual environment, meaning no drifts. So this is good, and it avoids having this Slack bot, and it's also a best practice to not have any drifts and to have the code in your main branch as your infrastructure that you actually have. The bad and the ugly here are not about using practices enforcement. It's like the other way around. If you don't use practices enforcement, then you will could face some security issues and have also non-compliant configuration get pushed to your code, and we don't want that. And on the right, I've put in some open source enforcement and helpers that will help you in your journey of integrating practices enforcement in your code base. Okay, so we asked the question, right? How do we envision the company and infrastructure needs? I hope that after I shared some things to consider in regards to Terraform, you can answer this question in your mind and say, yeah, I think I now know how we envision and do whatever is needed to do that. And if not, then don't rush the gun, don't jump the gun, right? Wait a bit. Think about it some more, because a lot of things that you do now will be hard to refactor and change in the long run. So it's better to plan ahead rather than not plan ahead and regret it afterwards. So I hope this is big enough. You tell me, but these are the key takeaways that I want you to take out of this presentation. So the code-based structure, if you think about it, then you will be able to set up Terraform as a platform and small state files, which is very, very important, and practice enforcement to help others help you. And you should really take into consideration use cases and pain points and even Terraform constraints, and where do you see the infrastructure management and company's needs in the long term, and plan accordingly. Because if we wouldn't plan accordingly, we wouldn't be able to set up the code base as we set in Wix, like I showed you. And even if you're a startup, you should think about scale, and you should think about how should you address and prepare for changes to come, and then you will be able to utilize Terraform in the best way possible. And I want to quote something else from Thyssen Gur, the person from the article that I mentioned before. He said, and I totally agree, that programs evolve, right, and code changes. And if I or any of you would use Terraform in one way and that's it, then I wouldn't be even here talking to you about Terraform practices. We will just use it the same way and that's it. But it's not the case. Stuff changes and code changes and evolves. And in order for us to switch from one current state to a desired state, this is the project, right? So in order to allow projects to get introduced to our environment, we need to think ahead and plan ahead, and that way we will be able to introduce projects and contribute to the company's success and also eventually our success. So these are the references that I mentioned throughout the talk, some guidelines about tagging, the workspace's documentation, the Tisin Goa article is very good, I recommend it. And Superlinter for the policy enforcement. It's a great bundle in Git that you can just use and incorporate in your implementation. So thank you so much. I really hope that you enjoyed it. I don't have time for questions, unfortunately. So if you have questions, you can catch me just outside. And that's it. Thank you so much.